Hello everyone. Good evening. My voice is clear. Hello. Okay, fine. Good evening everyone. I am Shomodip. I am from the Department of Electrical Engineering at Indian Institute of Science. I'm currently in my I've completed 3 years of my PhD and currently in the fourth year of my PhD. I am working on numerical techniques on electromagnetism and one of the applications of it. And I'm working on the area of lightning protection of aircrafts, where I use very frequently use different numerical techniques for calculation of electromagnetic fields. So I'll be handling this course as the TA for this course, numerical methods for engineers, which is being handled by Professor Niket Kaisare in the NPTEL portal, as you must have seen his recordings. So, everyone, can you please unmute and introduce yourselves so we'll be familiar? Pratishtha, can you introduce yourself? From where are you? What you are pursuing?
Yes, sir. Sir, myself Pratishtha from Gati Shakti Vishwavidyalaya, Vadodara, pursuing BTech Mechanical Engineering in Railway Specialization.
Okay, you are currently in which year of your BTech?
Second year, sir.
Okay, okay, fine. Nandini, can you please introduce yourself?
Good evening, sir.
Yeah,
This is
good
Nandini
evening.
Channa.
Hmm.
I'm from Dharwad, sir, but basically now I'm staying in Bangalore. So now, presently, I'm pursuing PhD in Manipal Institute of Technology, Bangalore, sir.
Okay, in which specialization are you pursuing your PhD?
Fluid mechanics, sir, in fluid
Okay,
mechanics.
okay, fine. Shrishti, can you please introduce yourself?
Yes, so myself, Srishi Chanderia. I'm pursuing currently BTech from Gati Shakti Vishwavidyalaya, Mechanical Engineering, and I'm in my second year.
Okay, fine. And other person, what is the name? Sri Priya, can you please introduce yourself? Sri Priya, are you able to hear? Hello?
Hello. Yes, I
Yeah,
can
Sri
hear.
Priya.
Yeah, it's
Yeah.
audible.
Yeah, can you please introduce yourself?
So I'm Sripriya from Kerala, and I'm doing BTech Mechanical Engineering third year.
Okay, fine. So are you able to see my screen? The notebook, are you able to see everyone?
Yes.
Okay. Okay, one more student has joined. Shanaf, can you introduce yourself?
Yeah, sure. So,
Yeah.
my name is Shanuf Ansari. I'm currently in my fourth year in my BTech from computer engineering.
Okay.
And the reason why I joined this course is because I wanted to kind of understand the basics. Like I wanted to like re-understand how things work, basically.
Okay. Okay, fine. You are from which place?
I am from Mumbai.
Okay. Okay, fine. You're able to see, everyone is able to see the screen? I'll-
Yes.
Okay. So every one of you have seen this week's recordings, the recorded classes, lectures of Professor Niket in the NPTEL portal. Everyone has seen that.
Yes, sir.
Okay, anyone who has not seen? Okay, fine. So I assume that everyone has seen. So Okay, so any one of you, so this is a live session. So basically, you will be seeing the recorded lectures for the first for every week, and you will come to this session so that you can clarify your doubts. And I'll also in the live session, I'll solve some of the problems which are given in your assignments, not the exact problems which will be given, but some of the related problems, and let's discuss the concepts behind that. I'll solve some of the problems in live in the class, and you can stop me in between any point when you want to ask anything, any doubts you have, you can just ask me anytime. Okay, you can unmute yourself anytime and you can speak up. So one mandatory thing is before coming to this class, that is this Saturday 7 to 9 p.m., you have to see the lecture of that particular week. Otherwise, it will be very difficult for you to relate to the class. Okay. So, okay. So I'll start off. So as the name of the course suggests, it is numerical methods for engineers, right? So anyone has any idea on what is numerical methods? What are basically numerical methods? Anything which you feel you can unmute yourself and speak. Any numerical method which you have used in your engineering, in your BTech or whatever degree you are pursuing, anywhere, any project you have used any numerical technique, anything? Anyone? You please speak up, everyone. Otherwise, I'll be just speaking. It will be of no use. So you have a basic idea on what numerical methods is, or you want me to describe it? Hello?
So we have used some direct and indirect methods in numerical methods.
Okay, can you name some of the numerical methods which you have used?
So Gauss elimination method,
Okay,
uh, Gauss-Jordan method,
yeah,
Gauss-Seidel method, and Jacobi-Seidel method.
okay, okay,
Then
fine.
bisection, all those things.
Okay, so what is the basic difference you find between the analytical methods and numerical methods? Anything which you have understood? Means what is the basic difference? Okay, so I will describe. So anything means when we have first learned mathematics in our school, we were taught of that. Suppose you have two numbers, say 2 and 2. So that gives rise to 4, right? So this is an exact solution. Means you know that if I add 2 and 2, I will get 4. There is no concept of error here or any approximate solution here. So this is an exact solution. But in real life, when you in your engineering also, if you want to solve any problems, like any in the from the electrical engineering perspective, I can talk of the electromagnetics, or from your mechanical engineering, you can talk of fluid mechanics. You have very complex equations, right? So it is very difficult. Any system or any phenomena in our physics or in our daily day-to-day lives, these are described by some differential equations, right? So it is very difficult to get an exact solution of any differential equation. So what we try to find out is we devise an algorithm or a method which gives me the solution, not the exact solution, but very close to the exact solution. So I'll give you an example which will make it very easy for you. So all of you have in the calculus in plus 2, in class 11 and 12, we have learnt of limits, right? So in limits, we always write limit x tending to a particular number, x tending to 2. So what does this x tending to 2 mean? It is not x equals to 2, right? So it is x is a value which is very close to 2. So that is an approximate thing. It is not the exact x equal to 2 we are stating. It is rather, so it is rather a very close to 2 that we are saying. So this is called an approximate understanding. So Now, so you have understood the difference between the exact solution and the approximate understanding, right? So the main motivation behind the numerical methods is all our real life problems, those are basically defined by many complex equations, right? So one more thing I wanted to ask everyone. I have not prepared any slides because this is a mathematics course, and I believe that if I write along, if I just if I use my scribble pad and write along with you, so that will be more efficient. Or do you want me to teach using slides? Or is this thing fine for you? Anyone, can you please give your feedback? Is this mode of teaching fine for you, or you want anything else? You can tell me. Okay, Nasim. Okay. So all our real life problems are defined by complex nonlinear equations for which we can't obtain exact solution. So what we do is we try to find the best solution for that equation. So we approach towards an approximate solution. So the method by which we approach towards this approximate solution, these methods or the algorithms are known as numerical methods. Just a second, I'll check whether the so the methods by which we approach towards these approximate solutions are called as numerical methods. So this is the basic motivation or why we study numerical methods. Obviously, questions will arise, right? We have definite methods, we have analytical methods which can give me the exact solution. So why do we want to devise a new method or the numerical methods? So this is the basic motivation because any real life problem which you encountered in your life, which you encountered in your engineering practices, that will not have a definite solution. That will not have an approximate solution because the equation which describes it is very complex and non-linear. So we cannot find an exact solution to that. So what we do is we try to approach towards the exact solution, but we know that we cannot go to the exact solution. So what we do is we just iterate over different through different algorithms. We definitely iterate and we try to move towards that solution. So this is what is the basic funda, the basic motivation behind any numerical method. Okay. So like another example I'll give you, that exact solution versus approximate solution. Like as I told, 3 plus 3 equal to 6. This is exact solution. Whereas approximate solution is like, you know the value of root 2, right? It is 1.4142. It goes on. We don't have an exact solution. We have to cut it at some point. We have to round off or we have to truncate. So these concepts of round off, truncation, all these things will come on as we progress. Okay. So this is an approximate solution. Again, we have E, right? Exponential of E. It is 2.718. It goes on like this. So we don't know what is the exact value of E. it is not either 2 not 3. It is 2.718 and it continues. So how do we represent it? Because it has an infinite number of digits, like pi, right? So it is basically we tell 3.14. It is not exactly 3.14. We round it off for our ease, we round it off up to 2 decimal places. Is this clear? Any doubts? Any confusion? Anyone? Any confusions? Anyone? Nandini, Naseem, anyone? Any confusions? Okay. Okay, fine. So now we'll start off with the course. So this was the basic introduction and the motivation behind the numerical methods. Now we sorry, I got disconnected. Okay, I'll continue. So what are the topics which I'll first list out what are the topics we will discuss for this class. That is week 1, right? So first we have discussed about the introduction and the motivation, right? So next are the errors and approximations. Then we will talk of truncation and the concept of truncation and round off. Then we will see the binary numbers and floating point numbers. Then we will see the different iterative methods, the numerical methods which are iterative. In that we will basically look into Hennon's algorithm. Then we will see the direct methods. Then we'll to look into the sequential methods. So first I will start off with this topic, the iterative methods on Hennon's algorithm. Okay. So have you seen the lecture of this, the Hennon's algorithm? Sir has very beautifully described the Hennon's algorithm. So what is Hennon's algorithm basically? So in numerical methods, what we do basically is first means we don't know what is the exact solution for an equation, right? So suppose here we are trying to find out the square root of say uh, 5. Okay. So we don't know what is the square root of 5. We don't have an exact method. So suppose you now forget what is the square root of 5 and you think that we want to evaluate it numerically or through different iterations. So what we will do in any numerical method, basically, first we have to set an initial value for a problem. we don't know what x is finally. But what we will do is we will set x equal to some value, say 0 we set. Then we will find what is, this is the x at the first step, that is the 0th step. So then we will use this value and find out x of 1. From this we will find out x of 2. From this we will find out x of 3, and like that we will progress. So you might question that till what iteration we will consider. So here basically the thing is, at every step when you find out this value of x, you have to check what is the difference. What is the difference between the previous value of x and the new value of x? So then if the difference is below a particular threshold, which will be mentioned in your question, so you can stop your computation, you can stop your calculation at that particular step. Okay, so this is the funda of any numerical method. Any root finding or any numerical method, if you go about, you have to assume an initial solution for that. I'll just repeat it. And using that initial solution, we will move in steps and we will find out, we will approach towards the exact solution. We can never get to the exact solution, but we will approach towards that approximate exact solution. Okay, so according to Hennon's algorithm, this x new, that is x at the next iteration, is equal to, so I'll write it a general one. Okay, suppose you have to find x equal to k to the power, so this is root 5 is basically 5 to the power half, right? And if you write cube root of 5, it is 5 to the power 1 by 3. So suppose you have to find out k to the power 1 by n, or rather let me write it like this, k to the power n. So suppose you have to find this where n is less than 1. This is strictly valid for n less than 1. So x new will basically be, one second, just a second, k to the power 1 by n, and this is valid for n greater than 1. Okay, so basically if you want to find the square root, then n will be 2, right? So basically the formula is x new is equal to 1 by n x plus k by x. So this is the new value of x, x new, and this x is the previous value of x. Okay, so here we are trying to find out the square root of 5. I'll do 2 problems on each concept. One I will do, the next one you have to do and tell me the answer. Okay, so first we will prepare a table. This is the number of iterations column. This is the value of x at that particular iteration. And for this class, everyone, you must bring your calculator. So then, so what will be x new for square root of 5 according to this formula? It will be x new will be equal to 1 by 2 x plus 5 by x, right? So k is basically 5 and n is 2. So we have to find out x of I, 5 by x of I, and x new, which is the summation of this x of I and 5 by x of I. So suppose first iteration is always 0th iteration. So what is x of 0? And in this problem, it is given x initial is 1. So this will be always given in your problem, the initial value of the solution. But what will, you may ask, what will happen in the actual when we are trying to solve any problem, any actual engineering problem? So there also you have to assume this initial value. Okay. So what is x of 0? 1. What is 5 by x of 0? It is 5. And x new will be equal to half into 1 plus 5, which is basically 3, right? So this is my x new at the end of the 0th iteration. So we will carry forward this value of x, that is 3, in the next iteration. So in the first iteration, x of I will be now 3. What is 5 by x of I? It is 1.666. Again, we will round off up to 3 decimal places. This will also be mentioned in your question. Up to how many places you have to find out. Is the thing clear to you? Any confusion? Anyone? Any doubts? So in the next step, can someone tell me what is the value of x nu at the first step? Please tell me what is the value of x nu at this step? Yes, correct. 2.333. So in the second step, again, we will do this 2.333. What is 5 by x? Can someone tell me? I'll find my calculator. Just a second. You please calculate and tell me what is the value. I'll find my calculator. So what is the value of x nu? 5 by x of I? 2.143, right? And x nu is basically 1 by 2. How much is the value of x nu? Yeah. 2.238. So you can see here in the first iteration we had the value 3, right? So then it changed to 2.333. So the difference was more. So now slowly you can see the difference between the successive values is reducing, right? It is 2.238. Then we'll move to the third iteration. It will be 2.238. What is 5 by x of I? 2.234. Correct. And this one is 0.5 into. It is 2.236, right? Yes, correct. So you can see here the difference is further reducing. So we want a value accurate to the third decimal place. So we will move to another iteration. So two decimal places are same. We want same in the third decimal place also. So that's why we move to the next iteration. 2.236. 236, and this is also 2.23. Is it correct? Okay. So you can see here. So now we stop our iteration because in the two consecutive iterations, we see that up to the third decimal place, our value is same. So that's why we don't progress any further. Suppose in your question, it is told you have to find your square root of 5 up to fourth decimal place. So in every calculation, you have to take your decimal places up to the fourth place, up to 4 digits after the decimal, correct? So then you have to continue the iteration until the 4 digits after the decimal place is same. Clear? Okay. Okay, fine. So I'll give one more problem. You try to solve this one and tell me the answer. Okay. You can just work out in your this paper and send the photo. Just click a snap of it and post it in the chat section. Okay. So you have to find out calculate fourth root of 10 up to 3 significant digits. Calculate the fourth root of 10 up to 3 significant digits using Hennon's algorithm. So can you tell me what will be the iterative equation or the formula for x new here? You can just unmute yourself and speak. What will be x new here? Anyone? Shrishti?
So for first iteration, we believe 1.
No, I'm telling like just here I wrote like x new is equal to half into x plus 5 by x, right? What will be this x new here for 4 if we want to calculate fourth root of 10?
Sir, it will be 1 by 4 x plus 4 by x.
Is it x plus 4 by x or x plus 10 by x?
10 by x.
Yeah. So the general formula you remove always. As I told here, if x is k to the power 1 by n, x new will be 1 by n x plus k by x. Okay? Okay. Is this clear? X new equal to 1 by 4 x plus 10 by x. So x0 I am telling you, just a second. So x0 you take it as 1. Okay? So now you prepare this table. Everyone please do this 0th iteration x of I, 10 by x of I and x new. At the 0th iteration, what is x of I? What is x of I at the 0th iteration? 1. Correct. It is given in the problem. 10 by x of I is 10 and x new will be 11 by 4, right? So it is 2.75. So in the first iteration, what will be x of I? 2.75, right? And 10 by 2.75 is, so I have told up to the third decimal place, right? So it will be 3.636. What is x new? What is x new? 3.193. How did you get? 1 by 4 into 2.75 plus 10 by 2.75. Right? Just check your calculation. Yes, correct, Nasim. Who replied this? Nandini, kindly check your calculation once. Srishti, kindly check your calculation. Okay, okay. So be careful of that. Don't divide by 2 always. If it is square root, then it is 2. Otherwise, it is 4, right? So it is 1.596. In the second iteration, it is 1.596. 6.265, 0.25 into. What is x new at the second step? Yeah, correct. 1.965. Again, you have to calculate third iteration. 1.965 by 1.965 is 5.089. 1 by 4 into 1.96. 763. Fourth iteration. Oh, you are too fast. Just a second. At the fourth iteration, it's if you type, no, everything is becoming just who has done it, please unmute and speak out. If you type, it is becoming very confusing.
Sir, it's 1.763.
At the end of third iteration, right?
Yes, sir.
At the fourth iteration, anyone has done?
One point 1.858, sir.
Yeah, correct. 1.858. So you are seeing that it is not converging, right? You have to continue it. I'll do for 6 iterations, then I'll stop. So it is 1.858, 10 by 1.858. What is the value at the end of fifth iteration?
It's 1.81, sir.
You have to write till third decimal, 1.810. So 1.810, 10 by 1.1524. What is the value at the end of sixth iteration?
1.833.
Yeah, 1.8. So slowly you can see the first digit has almost converged. Second is just one more iteration we will do. 1.833. What is the value at the end of?
1.833.
Yeah, correct. 1.82. So it's almost like 1.82 you can report. Okay. So, but you have to continue it. And you can see here that this Hennon's algorithm, that is basically true only for the, uh, as long as the power of this X, that is fourth root we are finding out. So it is becoming too much, means multiple iterations you have to do, and it is not converging. You can see up to the third decimal place. So it is basically more accurate for finding the square root and the cube root. As you go to higher powers, it is not accurate. So I just wanted to show you this fourth root, but generally fourth root, fifth root, we don't calculate it using this Hennon's algorithm. So you can see here the example. It is not converging to the till the third decimal place. Only it is converging till the first decimal place, right? So now you might ask another question regarding this Hennon's algorithm. Okay, so anyone has any questions? Anything? Okay, so fine. So here, this formula for square root I am writing, it is basically this, right? So how did this formula come? Means why are we using this x nu equal to half into x plus k by x? So I can give you just a graphical description of this. So if I consider this is on x-axis is the number of iterations. So x nu is a particular value, right? So we can find out. Just a second. So this is my x nu, right? Also, it will not be constant. This is the exact value of x nu, and basically it will oscillate, right? And gradually this iterative difference will come and it will converge. So if we try to plot what is x, Along the iterations, if we just try to plot what is x, so what we are basically doing is we will plot this x and k by x. So if you see here, it will be basically like this. It will be x, and what is k by x? K by x is another graph, which is like this. And gradually, both x and k by x will converge. So you can see here, see, basically first x and k by x was totally different. Then gradually, as we move through the iteration, x and k by x almost became equal, right? So here also you see, here since it is not the square root, here this thing will not work. So if we see x and k by x are converging, right? So once it has converged, we take the average of x and k by x, which will give us this value. This is the average value of x and k by x. Don't confuse, this is not the plot of x with respect to y. It is not y equal to x. It is just the plot of x over the different iterations and k by x over the different iterations. I've just tried to show you how this formula might have come. So this formula, mathematician Henan, he had maybe he had found it by some trial and error method, but we can try to give what might be a graphical interpretation of that formula. So it is basically, if we want to x equal to square root 5, we find out x and 5 by x. We find it out our different intervals, and once we see that x and 5 by x are almost equal, we average them and find out what is the square root of 5. Is this concept clear? One new student joined, I think. Yes, Sharfu.
Yes, sir.
So you joined the class late, right? So
Yes,
this
sir.
is so have you seen the lectures of this first week? The NPTEL lectures of professor?
Yes, sir.
Okay, so I have started a topic. So just let me know if you have any doubts from after this. This one almost I've completed, Henon's algorithm. Is it fine?
Yes, sir.
Okay, fine. So this is all about Henon's algorithm. So you have a problem in your assignment related to this Henon's algorithm. So I hope it is clear to you, and what is the physical interpretation of Henon's algorithm also I have talked about. Okay. So next topic we will move to sequential
Sir,
methods.
sir,
Yes. Yes. Yes.
sir, as you said, the red line is average of the x and 5 by x.
Yes. Correct.
Yeah. So that will be the true solution for x now.
That will be the true solution for x. Yes. Correct.
Okay, sir.
Any confusion? See, this is not the
No,
plot of x. This is just over the iterations, whatever we have obtained here. No, here if you just plot this x of I, this column, and 5 by x of I, you will get like that curve. And if you plot x new, that is the average of x of I and 5 by x of I, so that will also oscillate. But after the iterations, it will converge to a straight line. That's what I tried to tell.
okay, sir.
Okay, fine. Any other questions? Anyone? Okay, so next we will move to the
I have one more
sequential.
doubt.
Yes, yes.
So as we have taken the initial value as 1, we can
Hmm.
also take from 0.5, right, sir?
Yes, that depends on the generally for this course. Actually, in the means in our undergrad, whatever we have learned there, the initial value will be given to you in the problem. So
Okay.
if you are not given with the initial value, you can obviously assume. But depending on the initial value, the number of iterations will depend. If you choose a value, an initial value, which is closer to the actual solution, then you will means very soon you will converge to your actual solution. But if you say, suppose here my x of the square root of 5, the actual value is 2.236, right?
Yes, sir.
So if we choose an initial value of say 2 and then proceed, we will converge faster. We'll not require these 4 iterations even. But if we choose a value, say 1 we have chosen, we needed 4 iterations. If we further choose like 0 or 0.5, you will need 2 or 3 more iterations. So that is the difference.
Okay, sir.
Any other questions? Anyone? Okay, fine. So we'll move to the sequential methods. In sequential methods, first we will talk of Taylor series. All of you are familiar with Taylor series? Anyone that series, that formula, you know? Any one of you? Are you familiar with the Taylor series, or should I explain it from the basics?
Yes, sir.
Okay. Yes. Okay. You know the Taylor series, right?
Yes, sir. Yes.
Okay. So I'll just briefly tell about it. Yes.
Formula, sir. Should I tell the formula?
Yes. Can you tell?
It's a f of a plus h is equal to f of a plus h, f dash of a plus h square, f double dash of a divided by 2 factorial plus h cube, again differentiation of f double dash of a divided by 3 factorial, and so on, sir.
Yes. Correct. So this is basically the formula for Taylor series, right? So now suppose I want to find out from this, I will just write the question is calculate sine of 0.4 using Taylor series. Okay. So here, what is this h actually? H is called the step size. Okay. So in the question, it will be either given you in how many steps you have to find out the value, or the step size will be given to you. So here I am telling calculate sine 0.4 using Taylor series in a 4-step method. So we are telling 4-step method, right? So we have to go to 0.4 from 0 in a 4-step method. So what will be h? That is the first step. What will be h here? Can someone tell? What will be the value of h?
0.1, sir.
Yeah, correct. So it is basically the value which we at the value of x divided by the number of steps. So it is 0.1, right? So step 1, first we calculate. So we will move from 0, then we will go to 0.1, then we'll go to 0.2, then we'll go to 0.3, then we'll go to 0.4. Correct? Okay. And here one more thing I wanted to tell. So basically up to this we will take here, and these are called the error terms. Okay. So this term after the second term, that is from second order derivative of the function, the terms are very negligible. So we generally neglect that, and we calculate the value up to the second term. Okay. So basically first step we will be calculating sine of 0.1. The next page. So what is sine of 0.1? We can write 0.1 as 0 plus 0.1, right? So it is a is 0 here and h is 0.1. So what will be sine of 0 plus 0.1? Can someone tell? Just not the final value, just you tell me the expression in terms of the Taylor series. Anyone? Nandini, can you please tell what is sine of 0 plus 0.1 here? Just according to the Taylor series, you tell me. What was the Taylor series? It is f of a plus h equal to f of a plus h into f dashed a, right? So using this, can you tell me now? Yes, Pratishta, how you are saying 0? Can you please unmute yourself and clarify?
Sir, it is 0.1. Like it is f of a, that is sine 0. Sine 0
Yes.
plus
Hmm.
plus h f dash of a. So sine 0 is 0 plus h, that is 0.1, f dash of a means cos 0. So it will be like 0.1. It is not 0, it
Correct.
is 0.1.
Yes, correct. So f of x here is sine x, right? So f dashed x will be cos x. So 0.1 into cos of 0. So it will be basically 0.1. Is it clear? Okay. So this is step 1. Okay. Step 2. So we have computed sine of 0.1 to be 0.1, right? So sine, next we will go to sine of 0.2. So how can we write sine of 0.2? Can you tell someone else? Can you tell what is sine 0.2 in terms of the Taylor series? How you can write it? Pratishtha, can you mute yourself, please? Some background noise is coming. Yes. So sine of 0.2, how we can write it? It is basically sine of 0.1 plus 0.1. So how we can expand this? Yes, someone, can you tell what is sine of 0.2? Just using this formula, you have to write it. Are you able to get the thing, or is it becoming, am I going too fast, or what is the thing? If you don't interact, so this session will be very, means not useful for any one of you. I can just speak out and I can complete it. But so it is basically sine of 0.1 plus 0.1 cos of 0.1, right? So sine of 0.1 we have found out. It is 0.1 plus 0.1. What is cos of x in terms of sine x? Can someone tell what is cos of x in terms of sine x?
Root 1
No.
minus sine square x.
Correct. So it is 1 minus sine square x. So cos 0.1 we can write as 1 minus sine square 0.1. That is basically 0.1 plus 0.1 into square root of 1 minus Sine 0.1 was 0.1. So it is 0.01. So this, how much it comes out to be? How much it is coming? Correct. 0.199. This is the third step. Second step. Third step is sine 0.3. It is basically sine 0.2 plus 0.1. In the similar manner, you can write it is sine 0.2, 0.2 root over. Directly cos I am replacing by sine. So sine of 0.2 is 0.199. 0.2, 1 minus 0.199 square. How much it is coming? How much it is coming? Zero point 199 plus 0.21 minus 199. Can you check the calculation once again?
So
Check
it's
the
0.3910.
Is it 0.3910?
0.3910.
I am getting, just a second. Here I have done a mistake, I think. It is not 0.3910. Just check the calculation once again. Yeah, Shri Priya is correct. 0.2969, right? So it is not 0.296, it is 0.297. We have to round it off. Pratishtha, please check your calculation. And Nandini, please check your calculation once again. So in the fourth step, it is sine 0.4, right? So it is sine of 0.3 plus 0.1 root over 1 minus sine square 0.3. So 0.297. How much is this coming at the fourth step? Correct. It is 0.392. Okay, it is 0.392 at the fourth step. That is sine 0.4 is equal to 0.392. We have evaluated this using 4 steps, right? So you can just check in your calculator also. First change the mode to radians and then find out what is sine 0.4. It is coming out around 0.389. So we are almost close to that value. So it is 0.392 we are getting using our Taylor series. So one thing is there. Here it was told we have to calculate it in a 4-step process, right? 4-step method. So that made our H as 0.1. So if we further reduce our H, say we make H as 0.01, so we will require 40 steps. So that is not possible in our handmade calculation. We can obviously write a MATLAB code or some programming we can write and we can find out. We will see that it is more accurate. That is, we will move more close to the actual solution. So here we can also calculate it in 1 or 2 steps. So what will be if we want to calculate this sine 0.4 in 1 step? How will we do? Any idea? 1 step method, if we want to find out, what will be h first of all? What will be h? H will be 0.4. So directly we will write sine 0 plus 0.4 equal to sine of 0 plus 0.4 square root of 1 minus sine square 0. So 0 plus 0.4. So we'll get some value like this, 0.4. And actual value is 0.389. So you can see our actual value is 0.389. And from 1 step method, how much we obtained? 0.4. And by 4 step method, we obtained 0.392. So you can clearly see here the error. Here, see in the here the error is percentage. If we calculate 0.4 minus 0.389 by 0.389. If we calculate this, so error percentage is 2.83%. And in 4 step method, it is 392.3. Here the percentage error is 0.77%. So you can see as we increase the number of steps, my error percentage goes on reducing, right? As the error goes on reducing, and for 1 step process, error was 2.8%, whereas for 4 step process, it is only 0.77%. That is, more the number of steps or lower the value of h, we will get a more accurate or exact solution. Is it clear? Is it clear,
So I
everyone?
think in error we need to divide it by actual errors, actual value,
Yeah,
not actual.
yes, correct. Actual value is 0.389 from the calculator we obtained, right?
Okay, sir.
Is it clear?
Yes, sir.
So error is basically the obtained value minus actual value mod of this by actual value. So actual value is 0.389. In 1 step method, we got 0.4. So error was 2.83%. And in 4 step method, actual value is same, that is 0.389. In 4 step method, obtained value was 0.392. So if you just find out the error percentage, it is 0.77. Okay. So now we will move to the next topic. So binary and floating point numbers. So anyone has any idea on what is a binary number? What are the digits which are used to represent the binary numbers?
0 and 1, sir.
Yeah. So there are different, some four or five number systems, right? So in binary number system, numbers used are 0 and 1. What is the number system that we currently follow? That is our 0 to 9, the 10 digits we have, right? So what is that number system called? It is the
Decimal
decimal,
number system.
that is decimal number system. 0, 1, dot, up to 9. Any other number system you know? Anyone? Two more number systems are there. Any idea? So one is hexadecimal number system. Did you hear of this before? So here we have 16 digits. First we have up to 0 to 9, normal like our decimal. Then we have A, B, C, D, E, F. So our normal number system, 10 is equal to A here, 11 is equal to B, 12 is C, G is 13, E is 14, F is 15. I'll describe each of the number system in details. Next one is the octal number system. So here we basically have second, some student is joining, I think. So in the octal number system, we have 0 till 8 digits we have here, 0 to 7, and we represent all numbers using these 7 digits. So these are the 4 number systems. So first I will show you how to convert any the most familiar number system with us is our decimal number system, right? So I will just show you how to convert given any decimal number to our first binary number. Okay. Decimal to binary. Say we have the number. Do you have any idea on how to do these conversions between the number systems? Anyone has any idea? Okay, I'll describe it from the beginning. So suppose you have a number system, say 165. Okay, so smaller number we will take first. So we have the number 67. So if we write it to the base 10, that means it is a decimal number. Since there are 10 digits, we represent a decimal number like this. So you have to find out what is the equivalent binary. So binary, the base is 2 because there are 2 digits, right? So what we do is, so every point we divide this number by 2. So first we divide 67 by 2. How much we get? 32. And the remainder is 1. So we write like this, 32-1. Again we divide it. So we get 16 and remainder 0. Again we divide it, 8, remainder 0. So we continue till this digit, that is 8, which we are getting is 0. Okay, 4, 0.
Sir, initially it will be 33, I think so.
Sorry. Yeah, thank you. So now we move in this way from bottom to top. So 67 in the decimal number, it is equal to, see from here, 0, 1, 0, 0, 1, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5 zeros. Then 1.
So I think in the second step it will be 1, sir. Reminder will be 1.
Which step?
16. 16, 16.
Yeah, 16 if you divide by 2, quotient is 8 and remainder is 0, right? Okay, this step you are talking about.
It will be 1,
Correct.
sir.
Yes, correct. Sorry. So it is 1, right? Yes, correct. So 67 in the decimal system, it will basically represent 0, 1, 0, 0, 0, 0, 1, 1 in the binary number. So is this process clear? or should I describe it once again? Is it clear? Is it clear, Nandini?
Yes, sir, it's clear.
Okay. So now, yes, Leonardo, can you, what is the confusion? Can you tell me? I'll describe that again. Hello, Leonardo. What is the confusion? Oh, you joined late, right? Okay, so here basically we were talking of the different number systems, right? So the binary and the floating point numbers we are talking. So we have basically four number systems here. One is the binary number system, decimal number system, hexadecimal, and octal. So first we are looking into conversion of a decimal number into a binary number. So 67 we have taken an example. If we convert that into binary number, how we do it? So what we do is we divide by 2 this number until the quotient here, this one, becomes 0. So we go on dividing. 67 we divide by 2, we get 33 as the quotient and 1 as the remainder. Again 16 and 1. Like this we continue. And once we complete, we get 0 here. We take the number in the reverse direction, that is from bottom to top. So 67 in the decimal number, it basically represents 0, 1, 4 zeros, 1, 1. Is it clear, Leonardo? Okay, fine. So now we will see binary to decimal. Okay. So we will take the same number, that what binary number we obtained here. We will see whether we get 67 as the equivalent decimal number. So it is basically 0, 1, 4 zeros, 1, 1. 0, 1. So we need to convert this into our decimal number system. So how we do it? How we go about it? 0, 1. So you must remember that for any binary number, the first bit, this is called the sign bit. That is, if it is 0, then your equivalent decimal number which you will get is a positive number. If it is 1, it is a negative number. Okay? Clear? Okay. So what we will do is we will assign place values to these numbers. We'll start from the right hand side. We'll place 0 here. It is 1, 2, 3, 4, 5, 6. So then what we will do is we'll start from the right. So this number, it is 1, right? 1 into 2 to the power, the place value of that digit. Then 1 into 2 to the power 1 plus 0 into 2 square, 0 into 2 to the power 3, 0 into 2 to the power 4. So it is basically 1 plus 2 plus all our zeros. This is 64. So it is coming out basically 67. Is it clear? Any doubts? Anyone? Is it clear?
Yes, sir.
Okay. So I showed you how to convert a binary number into a decimal number and a decimal number to a binary number. Both ways I have shown you. So now I'll give one question. Try to solve this one and tell me the answer. So here we will not be talking about the hexadecimal and the octal numbers because that is not in your course. Just for to name the number systems, I named them. But basically in your course only conversion from binary to decimal and decimal to binary is there. So you do this one, convert the following 16-bit signed number to decimal. 0, 1, 0, 1, 0, 1, 1. Can you convert this into decimal number and tell me the answer? I'll give you 5 minutes. Everyone, please try to solve this one and find out what is the equivalent, this number. So first we will assign the place values, right? So this is given, it is a signed number, right? So this last bit is a signed bit. So this is 0. So the number will be positive, right? So here also it is positive. Okay, positive is understood. Now you find out what is the number. Can someone tell me what is the, after calculating how much it is coming? Yes, correct. Others, Pratishtha, good, you have completed. Yes, it is 349. So it is basically 1 into 2 to the power 0, 1 into, yes, correct. 1 into 2 square, 1 into 2 cube, plus 0 into 2 to the power 5. So it is 1 plus 4 plus 8, 256. So this comes out to be 349. Clear? Okay. So can I move to the next topic? 2 or 3 more topics are there. Is it fine for everyone? Any doubts? Anything? Any doubts? Anyone? Yeah, Srishti. Sure. 5 minutes break you can take. Okay, I'll take. Okay. It is 8:25. I'll start by 8:30. Will that be fine, Srishti? Okay, fine. I'll take a 5 minutes break. Just come back. Okay, so I'll resume. Srishti, are you back? Okay. Okay, fine. Okay. So we have almost come to the end of this class. Another 15-20 minutes I'll take. So this is basically we have completed the conversion from binary to decimal, decimal to binary. So now we will look into absolute concept of absolute and relative errors. Absolute and relative errors. So what is an absolute error and what is a relative error? So in numerical method, as I told you, you will not get an exact solution, right? So you will have to, there will be some amount of error. And our basic aim in any numerical method is to minimize the error to the maximum extent possible. So we try to minimize the error by multiple iterations if it is an iterative method, or by using a smaller step size if it is a sequential method like the Taylor series we saw, that is sequential method, or in Hennon's algorithm which we saw, it was an iterative method. If you increase the iteration, you will get a more accurate solution, that is a less error you will get. So what is an absolute error? Suppose your actual solution, actual value is P, and your obtained value, that is through a numerical method, you have obtained that value to be P star. So what will be my absolute error? It is basically mod of P minus P star. This is called the absolute error. And what is a relative error? It is mod of P minus P star by P into 100%, if you want the percentage relative error. So the concept of absolute error is not appropriate, I will say. Because suppose you have an actual value of say 0, actual value is say 0, 0.0, and you have obtained 0.5. So absolute error will give you what is the value? 0.5. So here you cannot find the relative error. 1 second. So it is 0.1. Okay. So what is your absolute error? It is 0.4. Right. So absolute error does not give you an exact picture of how accurate your solution is, because unless you have two values, you what is the main purpose of the error thing? It is basically to find out how close is my obtained solution to the exact solution. So here this absolute error is not giving you that picture. It is only giving you the difference between the actual value and the obtained value. However, relative error, if you see, it is calculating the error with respect to the actual value. So it is basically giving you how close you are to your exact solution. Okay. So here, if you find out the exact value, it is basically 0.4 by 0.1 into 100%. So your relative error is actually 400%. So from your calculation, you can understand that this 400% error is too much. So if your actual value is 0.1 and you are getting 0.5, that means your error is too much. That you can understand from the concept of relative error. But absolute error does not give you that picture. It tells you only the difference, which is 0.4. But from 0.4, you will feel the error is very less. But that is not. Because with what respect you are finding out. If this 0.4 was with respect to 1, suppose actual value was say 1 and your obtained value was say 1.4. Okay. So then also absolute error is 0.4. But the relative error will differ. It is 40% in the second case. So from the relative error, see, both if the actual value is 0.1 and obtained value is 0.5, and if the actual value is 1 and the obtained value is 1.4, both the things are not the same. The error is not the same here, but absolute error does not give you that picture. It tells you that the error is same in both cases, but that is misleading. Am I audible? There is some technical connection error. or you're able to hear me clearly?
Audible, sir.
Okay. Okay. So here you can understand what is the importance of relative error. So this example as I gave you, so you can understand from here what is the concept of relative error. So relative error, it gives you actual picture of the error. Is the difference between relative error and absolute error clear? Any doubts? Can I continue? Okay. Okay, fine. So we will do a question with this concept. Suppose P star must approximate P ten to the power minus 2. Find the largest interval in which P star must lie for P equal to 100. So here in this problem, it is telling that suppose P star must approximate P with a relative error of at most 10 to the power minus 2. It is 0.01. So your relative error is given as 0.01. Find the largest interval in which P star must lie for P equals to 100. So can you try solving this? In the lecture, sir has described this type of problems. Can you try solving this and tell me how you will proceed? Someone please tell me what is the concept, how you will proceed. So what is P and P star here? Which is the actual value and which is the approximate or the obtained solution? Others, can you tell? What 99 you are telling, Leonardo? Can you be specific? It is an interval which it is asking in which P star must lie. It is not a single value. Nandini, can you tell how we will proceed with this problem? Any idea? Anything you can tell me. This interaction will develop your ideas. That will also help me to learn. One has written. Yes, Pratishtha, can you please tell what you are telling? P less than equal to 99 or minus 99. What you are telling? Can you clarify kindly?
Sir, I use the formula P minus P star upon P mod is
Hmm.
it is given that error should be at most 10 raised to the power minus 2. So
Correct.
I did 100 minus P star upon 100 will be less than
Hmm.
equals to 10 raised to the power minus 2.
Yes, correct. Okay. It's
So
not
100
okay.
so
Please proceed.
100 minus P star will be less than equals to 1.
Okay.
So
Okay.
P star will be less than equals to 99.
Is it less than equal to or greater than equal to? Just check once.
Less than, sir.
Okay. Okay. I'll check. Okay. Good. Your idea is good. So what we will do here is we are telling that it should be at most 10 to the power minus 2. That is, it cannot be greater than 10 to the power minus 2. That is, the error should be less than equal to 10 to the power minus 2. Right? So we will find it for the maximum case. That is the limiting case we will find out. We will take it as 0.01. So P minus P star mod P minus P star upon P is equal to plus minus 0.01. Then if we substitute it, is 100 minus P star upon 100 is plus minus. That is, error can be plus or minus, right? So it is 100 minus P star equal to 1 plus minus 1. So P star can be, P star has to lie between 99 and 101. It should be greater than equal to 99 and less than equal to 101. So what Pratiksha said, I'll follow that process and check. So you said basically it is 100 less than equal to 0.01, right? 100 minus P star less than equal to 100.
Sir, it will be 1. Means 100 into 0.01.
Correct. So that is, you did a mistake here. If you solve this inequality, how much it is coming? Minus P star is less than equal to minus 99, right? So what happens if
Yes.
you multiply an inequality with minus? This sign gets reversed. That is, P star will be greater than equal to 99. Is it clear? See, if A, suppose a number is there, X, which is 0.1. If X is less than 1, then minus X will be greater than minus 1. This is the basic rule of inequality. Because if X is 0.1, which is less than 1, this is true. Then minus X is minus 0.1. But minus 0.1 is greater than minus 1, right? It is not less than minus 1. So the basic rule of inequality is, unlike if you have an equal to sign, say x equal to y, you can write minus x equal to minus y. But if x is less than y, then minus x will be greater than minus y. Is this clear?
Yes, sir.
You did a mistake in that inequality, right? Okay. So here you have found out P star is less than equal to 99, right? So how we will get that 101 then? So what we have to do is, for this you have to follow another step. 100 minus P star by 100. It should be less than 0.01, but it should be greater than minus 0.01, right? So it will be 100 minus P star will be greater than minus 1. So P star will be less than equal to 101. So from this you can write P star will lie between. So from combining both these inequalities, you can write that 99 less than equal to P star less than equal to 100. That is, P star will lie between 99 and 101. Is it clear? Pratiksha,
Yes,
is
sir.
it clear? Okay. Everyone? Okay. Srishti, it is clear. Nandini, is it clear?
Yes, sir.
Okay. Leonardo, you joined late. Is it clear? Okay. Okay, fine. So this is about relative error. This rounding off, I hope you all know. I'll just go through it in brief. So if I tell, suppose a number is there, 1.476789. So if I tell round it off, this is very basic thing. We have learned it in our school, I think, to 3 decimal places. What will be the answer? What will be 1.476789 rounded off to 3 decimal places? Anyone? Anyone? Any idea? Yeah. So what we do is we will see up to 3 decimal places and we will see the fourth place. That is one place after the third decimal place. And if it is less than 5, this digit, this 6 will remain as 6. If it is greater than or equal to 5, it will increase by 1. So here 1.476, fourth place is 7. So it will be 1.477. So one more, if we see 1.2342231. If I say it round it off to 4 decimal places. So since the fourth place we will see and fifth place is 3, which is less than 5. So it is basically 1.234. So in any numerical computation, you need to use this rounding off technique. Suppose your exact answer is 1.234231, but you are asked to take only up to 4 decimal places, then you will take 1.2342. This 31, 0.000031, this is your rounding off error or the round off error. Okay, the difference between the actual value and the rounded off value is known as the round off error. So in a iterative process, if you are rounding off at every step, this round off errors will accumulate, and the total error which we will get at the end of any numerical process. So this will be the sum of all the round off errors in the individual steps. It's clear? Clear, right? Okay. So today's last question we will do now. So here it is asked, write an algorithm So the question is, we have to write an algorithm or basically a computer program to find out the sum of this series I equal to 1 to n xi, that is the sum of n numbers in the reverse order. That is, so how you will go about this? This is a is a bit of the bit problem. I'll explain you how to do it. So what is this summation I equal to 1 to n xi? This is basically x1 plus x2 plus xn, right? So if you have to write everyone, you are means familiar with any programming language which you have used in your BTech or whatever course you are pursuing. You have used any programming language? Which language are you familiar with? At least MATLAB are you familiar with? Anyone is familiar with MATLAB? You can Python. Okay. So here I will not go into any programming language. I'll just tell you the algorithm. Okay, Srishti, no worries. I'll explain you. I'll explain what is the thing. So for to write any algorithm, first we have to decide what are the inputs, what is my output, and what are the variables, what is the process, what is the computation procedure which you are going to follow. So what are the inputs here? Means what we need to give to the system to find the sum of the series. We have to give x1, x2, xn, and the value of n. So if you give these values, then your algorithm will give you the sum of the numbers. Okay. So if you want to write output is the sum, right? So the process is Step 1, set. You take a variable sum and you set it to 0. So, Leonardo, you're familiar with the programming language, right? So, in yeah, n into n plus 1 by 2. So, that is using the analytical approach, right? So, we have to find it using our, we have to devise an algorithm for that. We directly cannot use that n into n plus 1 by 2 formula. That is basically the arithmetic progression formula you're talking about. Yes, that is correct, obviously. But here in this course, we are trying to write an algorithm. So, anyone familiar with for loops? The loops in programming languages? Anyone familiar with for loops? What is the function of a loop? What it will do? Any idea? Pratishta, Srishti, anyone? Okay, for loops you haven't used. Yes, Leonardo is correct. Iterate n times. Okay, so I have to describe you what is a for loop then. Nandini, are you familiar with it?
So I have just heard it in C programming language, sir.
Okay, okay. You are not familiar how it works, right?
No, sir.
Okay, okay, fine. I'll describe it. No worries. So, so then, okay, I'll write the solution for that. In the next class, just remind me, I'll describe you. Today, time is not there much. I'll describe you what is a for loop and how it works. Today, I'll do this solution and I'll explain you. Next class, I will definitely explain. Okay, is it fine? Okay. So, for j equal to 1 to n, I equal to n minus j plus 1, sum equal to n. So this is a bit difficult. Those who don't know what is the for loop, it will be difficult to understand. I'll try to explain you. So what a for loop does is it basically iterates, it repeats the same process for multiple times. So suppose my n I have taken as, suppose I want sum of 5 numbers. Suppose the numbers are 1, 2, 3, 4, 5, right? And in this question, it is told you have to sum of the finite series in the reverse order. That is, you have to do 5. Next step, we will do 5 plus 4. Next step, we will do 5 plus 4 plus 3, 5 plus 4 plus 3 plus 2. And last step, we will do 5 plus 4 plus 3 plus 2 plus 1. In this way, we will proceed. So first step, if we do 5, it is 5. Next step, 9, 12, 14. And here you will get the exact sum 50. So this process which we are doing in our hand multiple times, our computer, any programming language, it can do it. It has a loop. Loop means, you understand, right? We listen a music in a loop. That is, we listen the same music multiple times. So here also we are doing the same process multiple times. So what for j equal to 1 to n means is, j is a variable which I have assumed, and it will run from 1 to n. First step j will be 1. Yes, Leonardo, you're telling. Yes, correct, correct, correct. It can be used to find factorial also. So the basic loop for those who don't know what for loop is, I'm describing. So j will basically, first step j will be 1. N if you take as 5, suppose. First step j will be 1. Second step j will be 2. Third step j will be 3. Fourth step j will be 4. Fifth step j will be 5. Okay. So here, first step, if I show how it is working, first step, your j is 1. So from this, can you find out what is I? N minus j plus 1, right? So it is n minus 1, j is 1 in the first step, n minus 1 plus 1, which is n. and sum at the ith step. So sum equal to sum plus I. So initially sum is 0, right? So sum equal to 0 plus I. So it is basically n. In the second step, j will be 2. I will be n minus j plus 1. So n is n, j is 2 plus 1. So it is basically n minus 1. Now what will be sum in this step? Previously it was n. Now n plus n minus 1. So you are seeing, right? First step I took n, the next step n minus 1. So what will happen in the third step? N equal to 3. So j is equal to 3. I will be equal to n minus j plus 1 is n minus 3 plus 1, basically n minus 2. Sum will be n minus n plus n minus 1 plus n minus 2. Step 4, what will happen? J equal to 4, I equal to n minus j plus 1, n minus 4 plus 1 is n minus 3. Sum will be n plus n minus 1, n minus 2 plus n minus 3. Step 5, this will continue. So is this process clear? Is it clear? So since n was 5, we will continue this step till this n minus this thing will this is equal to 1. Now it will be 0. So we don't need to go any further. So if n is 5, it is equal to n plus 5 plus 4 plus 3 plus 2 plus. It will find out 15 as the sum. Is this algorithm clear? The algorithm is clear to everyone? Okay. Okay, then for today, we'll wind up the class here. One more thing, you will find the recordings of these lectures. NPTEL will send you. And one more thing which I can do is I can create a WhatsApp group. If everyone is familiar, if everyone is comfortable with that, please let me know. You can send me your WhatsApp numbers in this chat. I will add you to a group, and I'll also upload the recordings of the classes in YouTube, as well as the materials for this class, the notes which I have written. I'll upload this in YouTube, and the notes I'll upload in Drive, and I hope the NPTEL people, they will share it with you. I can create a WhatsApp group with everyone if everyone is comfortable with that. Otherwise, you can directly get it from the NPTEL portal also. The regular updates about the class I can give in the WhatsApp group if everyone is comfortable with that. So is it okay for everyone, or what platform you want to use? It's up to you. Only 4 people have given. Okay, fine. Leonardo, would you like to be added to the group? And you can post your doubts there. You can ask me anything which you want. Okay, fine. I'll leave it up to you. Okay, then it's today we'll wind up the class here. Is it fine for everyone? The pace of the class, everything, anything you can tell me. If you want, you can just tell me.